Hey everyone, happy Thursday. Of course, I'm not here today. I'm on campus. I'm just at meetings all day today. So we're still gonna go and start our new unit on polynomials. Polynomials. Whoops, let's go back. So I am gonna ask you guys to make sure that you guys set up your notes today. It's all gonna be just about vocab. So I'm gonna try to keep this video short, maybe 15 minutes long, simple. So make sure that you guys follow along and include the vocabulary and the examples in your notebook. Don't forget there is a notebook check tomorrow, Friday. So I will be collecting notebooks. I will be looking for these definitions. So let's go ahead and get started. If I do talk a little too fast, feel free to pause the video and again, watch at your own pace. Watch at your own pace. So today we're going to talk about polynomials. What are polynomials? We're going to talk about a couple definitions that involve polynomials. So here's just a preview of some things we're going to talk about. We're going to talk about the degree of a polynomial. We're going to talk about how do you identify the number of terms, basically how many parts there are. And then we're going to name these polynomials using specific names that they have. So I want to take you guys back though, before we get into the definitions, you guys have actually already been working with polynomials. I want to take you guys back to semester one. In semester one, you guys were writing expressions that represented kind of the following situations here. So for example, in semester one, we had examples that said, hey, a pizza costs $2 per slice. So how could we represent that? We used to say, hey, 2x, right? That represents $2 per slice of pizza. Let's go on to the next one. A pizza costs $2 per slice and hot dogs cost $3 each. So again, how could we represent that? We would say something like 2x to represent that it's $2 per pizza and plus, right? Plus, hot dogs are $3. So we have to use 3, but of course a different variable, something like y, 3y to represent that it's $3 per hot dog. So you could use h if you wanted to. And then the last one down here, it says a pizza costs $2 per slice. How can we represent that again? Well, let's go back. 2x. And then they charge you $1 if you use their credit or debit card, right? Sometimes they will give you that little $1 fee. So we're going to add $1, and we're not adding a variable to that because again, you're only paying that one time. But all of these three here are examples of polynomials. You guys have actually been working with polynomials. You just didn't know it. We didn't give you guys those definitions just yet. All right, so let me give you guys a couple of definitions here. Term, I will be using this a lot. So make sure that you guys get this down. So what is a term? What is a term? So a term, it can be a number, it can be a variable, or a combination of a number and a variable. So the product of a number and or a variable separated by a plus or minus. So in this first example, we have 2x. So again, that together right there is one term. So again, it's a number and a variable next to each other. The moment that you hit a plus or a minus sign, that is what separates your term. So take a look at the next example. We have 3x. And as soon as I hit to that minus sign, I must stop right there. That's my first term, 3x. The second term, that negative 1 would be the second term. That has two terms. And we can expand this. We can have something really long, something like 3x squared plus 4x minus 1. How many terms are in that one? Well, there's 3x squared. I hit the plus sign, I stop right there. That's my first term. Then I go plus 4x. Then I get to the minus sign. I'm going to stop right there before I get there to the minus sign. That's my second term, positive 4x. The last term is going to be that minus 1 or that negative 1. So this one actually has 3 terms. So I need you guys to get comfortable identifying your terms. Now, as soon as you start putting a bunch of these terms together, you start creating longer and longer polynomials. So what is a polynomial? A polynomial, our next vocab word here. It's a single term or a sum. It can be a combination of many terms with whole numbers as powers, right? So again, a polynomial, guys, I could have kept extending it here. This polynomial has 2x plus 3y. That has two terms, right? And of course, we could add another one, plus 5z. That could be the third term, right? And we can keep going with this polynomial, minus 1. That could be a fourth term, and this polynomial could go on forever and ever and ever. So again, these think of these like trains. Each one is a little cargo box. The next definition here, coefficient. What is a coefficient? A coefficient is the numeric factor of a term. Basically, it's the number in front of the variable. So if you guys want to write that instead of this definition, coefficient is the number in front of the variable. So if you have something like a term like 2x, well, the coefficient is just the number in front. That 2 is what we call your coefficient. And again, I will be using that word a lot for this unit. Coefficients are the numbers in front of a variable. Now, what is a constant term? Well, the constant is a term that contains only a number, so no variables attached to it. So if you look at this polynomial here, the 2x, as soon as I hit the plus, that's a second term. Well, which one right there is the constant? See how the 2x has a variable, the 2 has a variable next to it? That is not the constant. The constant is that lonely number all by itself. So the plus one there is what we call your constant. So make sure, guys, that you guys copy these definitions down inside of your notebook, please, exactly the way that you guys see it. If you need to pause the video here, of course, pause it. Let's move on. So example one, we'll do it here. I'll do it for you guys. The next one, I'm going to ask you guys maybe pause the video and then try it on your own. Get comfortable using these vocab words. Tomorrow we are going to hit the ground running. So how many terms are in this polynomial? So look at this giant chain of terms attached to it. Let's break it down so we can focus on the individual pieces, right? I always like to think of them as pieces, and I like to put them like in little baskets. So I'll explain what I mean by that in a second. So let's start at the beginning. 2x to the third power. As soon as I hit that minus sign, I'm going to stop right there. That's my first term. And then that minus or negative 4x to the second power plus. As soon as I get to that plus sign, I'm going to stop right there. That's my second term. Plus x. I'm going to stop right there. That is my third term. And don't forget, there's that special one that we don't see there. I'm going to write it in there if it helps you. And then the last term here is the plus 1. So how many terms in this polynomial? There are 4 terms. That's all we have to say. How many terms? We just say 4. You could add the word terms there if you really wanted to. What are the coefficients? So let's take a look at the coefficients. What is a coefficient? Again, coefficients are numbers in front of a variable. So here I see that I have a variable x. The coefficient is a 2. So that is one of my coefficients. Let's keep going on to the next term. The next term over here, I see I have an x to the second power. Well, what's the number in front of that? Careful, that's not just a 4. That is a negative 4. So negative 4 is my second coefficient. And then, of course, I see the third variable over here. The number in front of it, that positive 1, and positive 1 is going to be my last coefficient. Why is that 1 at the very end not a coefficient? That's actually something else that we call the constant. Remember, the constant is the one that does not have any variables attached to it. It's that lonely number. Here we see that the plus 1 is all by itself. So what is the constant? It's just the 1 in that chain. All right, so get comfortable, guys, using these vocab words. We're going to use them a lot. I'm going to ask you guys, pause the video here, and then you guys try it out. When you're ready, go ahead and hit play, and I will give you guys all the answers. So here are the answers. So how many terms do we see in this polynomial? There's 3. So again, there's 1, there's 2, and there's 3. And again, they're separated by every time you hit a plus or minus sign. That's what separates your terms. Which ones are our coefficients? Again, our coefficients are the numbers in front of the variables. So there was that negative 1. Don't forget about the negative. And then there was that positive 4 in front of that other x as well. The last one is the constant. Again, the constant term is the one that doesn't have any variables. So that was just a negative 2 at the end. All right, moving on. So the next one here, you don't have to copy this one down, but we're going to use the degree in a little bit. We're going to talk about powers. We've been talking about exponents. So what is the degree? You don't have to copy this definition. This is just a very nice to know one. You'll use this more in algebra too. So the degree of a polynomial, it's the greatest power of any term in the polynomial. So if we take a look at the first one here, there is one term, 3x to the 7th minus, stop right there. There's a second term, negative 4x to the 3rd. There's a third term, plus x, and then there's that minus 1. So there's 4 terms. But look at their exponents. Look at the powers. There's a power of 1 here. There's a power of 3. There's a power of 7. This guy at the very end doesn't have a power, right? It would just technically be 0 there. So what is the degree of the whole polynomial? What's the biggest number we see? The biggest exponent, I should say. Let me be specific. The biggest power, the biggest exponent is 7. This is a 7th degree polynomial. And again, you won't use this in Algebra 1, you use this a lot more in Algebra 2. It's a nice note, but it leads into my next definition on the next slide. So the next one, let's take a look at the next one. What is the degree of this one? There's 5x squared plus, and then there's a plus 6. So look at your terms. Which one has the biggest exponent? There's a 2 here. There's no exponent on this guy. So 2 is going to be the degree of this polynomial. It's a 2nd degree polynomial. All right, let's do the last one here. How many terms do we have? We have 1, 2, 3. What is the biggest exponent we see? It is going to be that 3 at the very end. That is a 3rd degree polynomial. Now, why are we talking about powers, right? We kind of just finished a unit talking about exponents and powers. So that leads us to our next definition, standard form. This is the one we're going to use a lot, especially tomorrow when I get back. Standard form of a polynomial. Make sure you guys copy this definition down, please. It is a polynomial whose terms, so all those tiny little chunks, all those tiny pieces, we write them in descending order. That means from biggest to smallest, based on their degrees, based on their powers. So what we're going to do here, I'm going to convert all these 3 examples here. I need to rewrite them in standard form. I need to organize it. This is where my OCD should kick in. I want to put everything in the correct order. So let's take a look at the first one. We have 7x we have a negative 4x to the third, and we have a positive 1. I need to put those in order from biggest exponents to smallest. So what's the biggest exponent I see? The 3 there. So we're going to bring that one down first. Negative 4x to the third power. That one's taken care of. That term's gone. Which one is the next term with the biggest exponent? Well, there's technically a 1 right here, so that should come next. That is a positive 7, so we're going to put plus 7x, and that one's taken care of. And of course, the last one here is the plus 1. Now, notice your polynomial. Notice your polynomial now. It is what we call standard form, from biggest exponents to smallest, right? So let's try the next one here. Let's try the next one. I have a 7 as my first term. I have a negative 4x to the second power plus, that's the second term, and then a positive 2x. So let's go ahead and reorganize that. So which one should come first here? Biggest exponent I see is a 2. So we're going to put negative 4x to the second power. That's taken care of. That's taken care of. The other biggest exponent is a power of 1 here. We normally don't write it. So I'm going to put positive 2x as my second term. And then, of course, the last one here, that is a positive 7. So we're going to put plus 7 at the end. And notice how that constant, the one that doesn't have a variable, is typically the one at the very, very end, right? So again, this is going to be important. We always want our answers to be in standard form. All right, the last one here, how many terms do we have? We have 8x to the third, that's my first term, minus 7x is my second term, plus 4x to the second power is my third term, and minus 3 is the last term. So let's go ahead and again put it in that standard form. Biggest exponent I see is a exponent, a power of 3. So we're going to bring that one down first. 8x to the third. Get that out of the way. The next biggest exponent I see is that power of 2, and that's the 4x to the second power, that positive 4x to the second power. We're going to bring that down. And then, of course, the next one here is that invisible one we don't see. So that's that minus 7x. And finally, the last one, right, is our constant, the one that doesn't have any variables attached to it, that minus 3. Again, that constant should always be at the very tail of this polynomial. All right. What I want you guys to do is I want you guys to try these next 3 on your own, right? When you're ready, go ahead and hit play. So again, pause the video, try it on your own. When you're ready, go ahead and hit play, and you'll see your answers pop up here. All right, guys, there you go. There are your answers. I think this last one kind of makes it very, very pretty clear here, right? Take a look at your exponents. We go from 7 down to 6, down to 4, and of course the constant at the very end doesn't have a power here, a degree. So there it is, standard form. Make sure you get this down. We're going to use this, like I said, a lot. This is probably going to be like the most important step for what we do tomorrow. Okay, the last thing is what I need you to copy is this section right here. There's specific names when it comes to the number of terms. So if something only has one term, we call that a monomial, right? That's the technical name for it. If something has 2 terms, right, like a 3x plus 2, we call that, like a bicycle has 2 tires, 2 wheels. We're going to call that a binomial. This has 2 terms. And what about if it has 3 terms? Well, like a tricycle, we're going to call this one a trinomial. Anything that has 4 or more terms, we at that point just start calling it a polynomial. All right, so make sure you guys copy that down. So let's take a look at the next set of examples here. So name the following polynomials. So look at the first one here. It has 2 terms. So we're going to call that a binomial. All right, the next one here has 3 terms. We're going to call that a trinomial. The next one here has 1 term, so we're going to call that a monomial. I think I spelled trinomial wrong. Whoops. Trinomial. And then the last one here has 1, 2, 3, 4 terms. That one, at that point, we just start calling it a polynomial. You can call all of these polynomials, but again, anything that's 4 or more, we just start calling it a poly. 3 or less, they have specific names. All right, guys, here is your class activity. I'll do the first one for you just so you guys get an idea of what you're supposed to do. So number 1 here, I'm running out of time. I'm trying to keep it under 15 minutes. The number of terms. How many terms in this first polynomial? There's 1, there's 2. So all you have to do is say there's 2 terms. What do we call it when there's 2 terms? We call that a binomial. What are the coefficients? The numbers in front of our variables. I see a 3, and I also see that -5 in front of the x. What is the constant term? Well, is there anything that doesn't have a variable next to it, like this 6 down here? Nope. So this one actually has no constant terms. There's none. That sometimes does happen. And then the degree of the polynomial, what's the biggest exponent we see on there? That is the number 2. So this is a second degree polynomial. All right, guys, I need you to finish this up. When you are done, check your answers with the sub. They have the answers. and then go ahead and turn it into the inbox. Have a great day, guys. Take care. See you tomorrow.